Scientists have just detected something unusual spreading across the Pacific Ocean. A gigantic mass of abnormally warm water is rapidly expanding near the equator, and some researchers say it is showing characteristics associated with the early stages of a potentially powerful El Niño event. The discovery is attracting attention because the Pacific is not simply warming. In some areas, temperatures have surged far above normal levels over an enormous region spanning thousands of kilometers. And when something like this happens in the Pacific, the effects rarely stay there. The Pacific Ocean covers more than 165 million square kilometers, making it the largest body of water on Earth. Because of its size, even relatively small temperature changes can influence weather systems across entire continents. What scientists are seeing now is a growing reservoir of warm water, both at the surface and beneath it. According to ocean monitoring systems, parts of the central and eastern Pacific have recently recorded temperature anomalies exceeding 2 degrees Celsius above average. That may not sound dramatic, but across such a vast area, it represents an extraordinary amount of excess heat. And that heat is beginning to move. Researchers are particularly interested in what is happening beneath the surface. Satellite measurements and ocean buoys have identified large subsurface warm water pools stretching thousands of kilometers across the Pacific. These hidden reservoirs often act as fuel for developing El Niño events. As the heat rises toward the surface, it can strengthen atmospheric changes and amplify weather disruptions around the world. And this is where things become serious. Several of the strongest El Niño events in recorded history began with similar patterns. The famous events of 1982-83, 1997-98, and 2015-16 all started with expanding warm water anomalies before eventually reshaping global weather for months. The 1997 event became one of the most expensive weather-related disasters ever recorded, causing more than $30 billion in damages worldwide. Floods, droughts, crop losses, and extreme storms affected countries across multiple continents. Scientists are not saying that current conditions will necessarily reach that level, but they are saying the similarities are difficult to ignore. The reason El Niño attracts so much attention is because it effectively reorganizes parts of Earth's climate system. Normally, trade winds push warm Pacific water toward Indonesia and Australia. During El Niño, those winds weaken, allowing warm water to spread eastward toward the Americas. That shift changes rainfall patterns, storm tracks, temperatures, and ocean circulation on a global scale. In some regions, it brings destructive flooding. In others, severe drought. And because the atmosphere is interconnected, the effects can appear thousands of kilometers away from the Pacific itself. What makes the current situation especially unusual is that it is developing during a period when global ocean temperatures are already breaking records. In recent years, multiple ocean temperature records have been shattered. Some researchers describe the current oceans as carrying an unprecedented amount of stored heat compared to previous decades. Now, an El Niño event may be forming on top of that already elevated baseline. Some climate scientists believe this combination could amplify certain weather extremes if the warming continued. Meteorological agencies around the world are increasing monitoring efforts. Satellites, ocean buoys, underwater sensors, and atmospheric models are being used continuously to track the evolution of the warming pattern. The goal is simple: determine whether this is merely a strong El Niño or the beginning of something much larger. Several regions could feel the effects first. Parts of South America often experience increased rainfall during major El Niño years. Australia and Indonesia frequently face increased drought risk. Certain parts of North America can see altered winter storm patterns, while some tropical cyclone regions become more active and others less active. The exact impacts remain uncertain, but one thing is becoming increasingly clear. Scientists are not looking at a localized weather anomaly anymore. They are watching a climate pattern powerful enough to influence conditions across much of the planet. And right now, that pattern appears to be growing. Because beneath the Pacific Ocean, an enormous amount of heat is moving into position. And if current trends continue, the weather maps of the world may start looking very different in the months ahead.
The next global disaster won't begin with a meteorite or a giant tsunami. The culprit might be warm ocean water. A powerful climate pattern called El Niño could develop in 2026, and it may become the strongest one in more than 100 years. In the past, a similar El Niño triggered droughts and a famine that wiped out up to 60 million people. Now, El Niño is a climate pattern that starts in the Pacific Ocean. Huge areas of water near the equator become much warmer than normal. And we're not talking about a tiny patch of ocean. That warm water can spread for thousands of miles. When that happens, weather all over the planet goes crazy. Some places get massive floods, while others stop getting rain completely. Winds shift, storms move, and seasons change. And that's exactly what might have triggered the disaster in 1876. Massive droughts spread across Asia, Africa, and South America. Rain disappeared for months, and rivers dried up. Crops failed over enormous areas. Over the next 2 years, millions of people were slowly starving. Historians think that up to 3% of the world's population didn't survive this disaster. Even today, it remains one of the most fatal catastrophes in human history. Scientists believe that the El Niño from the late 1870s may have been one of the strongest ever recorded. Now, how did they figure it out? Obviously, nobody had satellites in the 1800s. There were no weather apps or climate models or modern instruments. So researchers had to investigate the past almost like detectives. And one of the biggest clues came from trees. You see, every year, a tree grows a new ring inside its trunk. In wet years, the rings grow thicker because the tree gets more water and grows better. During droughts, the rings become thin and weak. So trees basically store weather records inside themselves. Scientists studied giant drought atlases built from tree rings gathered from all over the world, with some of those records going back hundreds of years. And they showed something alarming. Apparently, during the famine years, huge parts of the planet experienced extreme drought at the same time. Then, researchers checked old rainfall records from thousands of weather stations worldwide. Finally, they compared them with ocean temperature records gathered by sailors in the 1800s. All the evidence pointed to the same thing. The Pacific Ocean likely seriously warmed up during those years, and that's exactly what happens during an El Niño. But that one may have been way more extreme than normal. The event likely lasted around 16 to 18 months, several months longer than many other El Niño events in recorded history. That extra time matters a lot, because the longer the Pacific Ocean stays unusually warm, the longer weather systems around the world remain broken. Some regions experienced droughts for several seasons in a row. Rainfall dropped to record lows in several parts of the planet. It hit Asia especially hard. Scientists found that parts of Asia went through the worst drought in about 800 years. Crops failed across huge regions, instead of only one country or one farming zone. The thing is, a drought alone does not automatically lead to mass starvation. But when huge crop failures happen at the same time as food shortages and bad transportation, millions of people can suddenly end up with no food reaching them. And that's exactly what happened during the global famine. Anyway, El Niño could explain why weather patterns broke down across multiple continents at once. Even though modern technology makes us far more advanced than people from the 1870s, we still depend on stable weather for food, farming, water, and electricity. and El Niño has the power to disrupt our planet on a gigantic scale. The most unsettling part is that the past disaster was not caused by some single freak event. Researchers believe that those conditions develop naturally, and Earth's climate system is very capable of producing something this extreme again. Today, the world is much hotter than it was in the 1870s, so if another Super El Niño appeared in the future, could droughts become even more severe? An El Niño can mess with the weather almost everywhere on Earth at the same time. One of the first big changes often happens during hurricane season. Normally, the Atlantic Ocean produces many tropical storms and hurricanes. But a strong El Niño can create powerful winds high in the atmosphere. Those winds basically tear storms apart before they can fully grow. So, places like the Caribbean and parts of the Atlantic sometimes see fewer hurricanes during strong El Niño years. But in the Pacific, it's the opposite story. Storm activity often ramps up in the central and eastern parts of the ocean. That can bring trouble for places like Hawaii, and sometimes even the southwest U.S. if storms move in that direction. Then winter hits, and this is when El Niño starts shaking things up in North America. The northern U.S., western Canada, and Alaska usually turn warmer than normal, and some areas get less snow. But it doesn't mean these regions don't have winter. Cold snaps can still show up out of nowhere. At the same time, the southern U.S. often gets wetter. A stronger jet stream, which is basically fast wind high in the sky at around 30 to 45,000 feet, pushes more storms across the south. They bring heavy rain, flooding, and cold weather to regions that are usually much drier. Other parts of the world can get hit even harder. For example, India and parts of Southeast Asia often lose important summer monsoon rains during El Niño years. And those rains are critical because hundreds of millions of people depend on them for farming and water supplies. The monsoon weakens, drought spreads fast. The Caribbean also gets much drier than normal during a strong El Niño. In some areas, there are even water shortages and crop damage. In Southeast Africa, drought conditions can become dangerous during the Southern Hemisphere summer, especially from December to February. A powerful El Niño may already be building in the Pacific Ocean right now, and some researchers think it could become one of the strongest ever recorded. Ocean temperatures in part of the Pacific are heating up fast. In some places, the water might become more than 5 degrees Fahrenheit hotter than normal. But for the planet's climate system, this difference is massive. The danger is actually even bigger than it looks. Today, we have better technology, satellites, forecasting, global communication. But our society still has weak spots. Food supply chains are actually under pressure, and many regions are also dealing with drought. Ocean temperatures have been breaking records for years. Some farming areas are becoming less stable because of the weather changes. Extreme weather events are becoming more spread out every year. A strong El Niño could pour gasoline on all of that. Scientists are especially worried about how unpredictable the weather could become over the next year. Oh, by the way, El Niño is just part of a big cycle. Normally, winds near the surface of the Pacific Ocean, called trade winds, blow from east to west. They push warm, sun-heated water toward Asia. At the same time, colder water rises up from deep below near North and South America. This is the reason why the ocean surface ends up uneven. The water near Indonesia can be about 1.5 feet higher than near Ecuador. But sometimes, those winds weaken. When that happens, the warm water starts sliding back toward the east. The eastern Pacific heats up and the western side cools down. That's an El Niño. If the opposite happens and the trade winds get stronger, even more cold water rises from the deep ocean. As a result, the Pacific cools down more than usual. That phase is called a La Niña. El Niño and La Niña are basically two sides of the same system. Together, they're part of a cycle called ENSO. Usually, an El Niño lasts about 9 to 12 months, while La Niña can stick around for 1 to 3 years. But not all El Niños are the same. The classic type is called an Eastern Pacific El Niño. That's the one where the eastern side of the Pacific warms up the most. But there's another kind called a Central Pacific El Niño. In this case, the warmer water sits more in the middle of the ocean. Well, if it seems like things on Earth aren't already strange, our home planet just got a little stranger. There's a hidden symmetry that nobody knew about. Now, scientists are trying to figure out why this symmetry exists. And the strangest part, the answer may involve one of the most powerful and disastrous climate systems on Earth, El Niño. There's this curious thing about Earth. If you split it into the northern and southern hemispheres, you'll see that they reflect almost the same amount of sunlight back into space. But they look completely different. There's more land up north and more ocean down south. There are different clouds, different weather, and still the energy balance is almost equal. The clever term for this phenomenon is hemispheric albedo symmetry. It's a bit of a mystery for us, but the reason might be simple. The southern hemisphere has more clouds that bounce sunlight back. At the same time, the north has more land and pollution particles that also reflect light. It somehow evens out. But then, things get more interesting. A group of scientists started questioning, what if this balance isn't only north-south? What if Earth is also balanced in a different direction? They dug into satellite data and found something surprising. There seems to be an east-west balance too. It's not a perfect line you can draw on a map, of course, but statistically, it shows up. If you split Earth along the 27° east and 153° west meridians, you'll get two halves that reflect almost the same amount of sunlight. That line cuts through Europe, Africa, Turkey on one side, and there's Alaska and a big part of the ocean on the other. Admittedly, these are very different places, but the numbers match. To figure it all out, researchers used 25 years of data from NASA's Ceres satellites, from 2001 to 2025. These satellites track how much sunlight Earth gets and how much it sends back into space. If the numbers are steady, the planet's temperature is stable. But if they change, the weather starts warming or cooling. The research team broke everything down: oceans with no ice, with ice, land, cloudy skies, clear skies, every piece of the system. And then they tested different ways of slicing the planet to see if any pattern stayed stable. Well, one of them did. That 27° east line kept showing a bizarre kind of balance. Both sides ended up with almost the same mix of ocean and land and a similar volume of clouds. They even had similar amounts of sunlight reflected from clear skies. At first, the researchers were skeptical. After all, Earth is a sphere, and if you slice it in enough different ways, you can sometimes find patterns that don't really mean anything. But when they started testing this pattern more, it didn't disappear. Even better, it showed a triple symmetry. First, this is the only east-west line that creates this balance. Second, it doesn't drift. It stays basically locked at 27° east all the way from 2001 to today. And third, both halves of the planet end up with almost identical amounts of land and ocean. But then, the question is, what's actually causing this symmetry? Right now, everything points to ENSO, the El Niño Southern Oscillation. That's basically a massive cycle where the Pacific Ocean shifts between warm and cool phases. ENSO shows up every 2 to 7 years. And it keeps flipping between three states: El Niño, La Niña, and a neutral phase. El Niño is the warm phase. The trade winds, permanent winds that blow from east to west at the equator, get weaker, or sometimes even reverse. That allows warm water to pile up in the Central and East Pacific. Meanwhile, cold, deep water near South America stops coming up. This pattern affects the whole world. There is more rain in parts of the Americas, but the weather gets extremely dry in places like Australia and parts of Asia. La Niña is the opposite. The trade winds get stronger than usual and shove warm water towards Asia. As a result, more cold, nutrient-rich water ends up in the eastern Pacific. So, the weather usually gets wetter in Australia and Indonesia, and drier in parts of the southern US. And then, there's also the neutral phase, when nothing exciting is happening and ocean temperatures are closer to normal. There's another curious fact. The name of this weather pattern also splits the system in two. El Niño La Niña is the ocean part that's linked to temperature changes in the Pacific. But Southern Oscillation is the air part, meaning changes in air pressure between the Western Pacific near Australia and the Eastern Pacific near Tahiti. And because the Pacific is massive, this one system ends up influencing the entire world's weather: rainfalls, floods, droughts, heat patterns, even hurricanes. Now let's get back to that symmetry idea. The researchers noticed that the tiny year-to-year shifts in that east-west balance seem to line up with ENSO changes, and they couldn't explain it without something called the Walker circulation. It's basically a huge loop of rising and sinking air over the Pacific, which connects cloud systems all over the tropics. It's like a giant conveyor belt, moving heat and moisture around the planet. That circulation changes where clouds form and how much sunlight gets reflected back into space. So, during La Niña, the eastern hemisphere reflects a bit more sunlight. During El Niño, the western hemisphere takes over. The system keeps flipping back and forth, and over time, it kind of anchors that symmetry line near 27 degrees east. Now, this means Earth's climate isn't a set of separate systems, it's all connected. And here's why we should care. We already know that Earth's albedo symmetry controls how much solar energy gets reflected back into space. Right now, it's about 29%, and even small changes in that number matter a lot for global warming. The problem is, many climate models still don't reproduce this east-west symmetry correctly, and we need to change that, because if a model misses this pattern, it might also miss something even more important. And that's where things get a little worrying. The same climate system that helps maintain this balance is also responsible for El Niño and La Niña. And some researchers think the next El Niño could become the strongest in more than 100 years. It might hit already in 2026. Back in the past, a similar El Niño triggered droughts and a famine that wiped out up to 60 million people. In 1876, massive droughts spread across Asia, Africa, and South America. Rain disappeared for months, and rivers dried up. Crops failed over enormous areas. Over the next 2 years, millions of people were slowly starving. Historians think that up to 3% of the world's population didn't survive that disaster. Even today, it remains one of the most fatal catastrophes in human history. Now, even though modern technology makes us far more advanced than people from the 1870s, we still depend on stable weather for food, farming, water, and electricity. And El Niño has the power to disrupt our planet on a gigantic scale. The most unsettling part is that the past disaster was not caused by some single freak event. Researchers believe that those conditions developed naturally, and Earth's climate system can easily produce something this extreme again. Today, the world is much hotter than it was in the 1870s. So, if another Super El Niño appeared in the future, droughts could become even more severe. A powerful El Niño may already be building in the Pacific Ocean right now, and some researchers think it could become one of the strongest ever recorded. Ocean temperatures in part of the Pacific are heating up fast. In some places, the water might become more than 5 degrees hotter than normal. For the planet's climate system, this difference is massive. The danger is actually even bigger than it looks. Today, we have satellites, forecasting, global communication. But there are still weak spots. Food supply chains are actually under pressure, and many regions are already dealing with drought. Ocean temperatures have been breaking records for years. Some farming areas are becoming less stable because of weather changes. Extreme weather events are becoming more spread out every year. And a strong El Niño could pour gasoline on all of that.
Go buy yourself a good pair of rain boots and start stocking up on food, because a Godzilla El Niño might be on the way. If it really happens, parts of the southern United States and southern Europe could soon be hit by intense rainfall and face a much higher risk of flooding. The same goes for South America. A series of catastrophic rainstorms could flood roads and trigger huge mudslides in countries like Peru and Ecuador. While some places deal with too much rain, others may get none at all. Indonesia and Australia, for example, might experience severe drought, which could cause massive wildfires and wipe out their water supplies. Experts think El Niño could happen sometime between June and August of 2026 and stick around until the end of the year. There's even a 1 in 3 chance it could turn into a Super El Niño by late fall. I mean a really intense, catastrophic version of this event that's also known as the Godzilla El Niño. The problem is, even if you're in part of the world that isn't directly affected by this phenomenon, you might see its consequences anyway. Because it can ruin crops and cause global food shortages. That makes your everyday groceries like rice, coffee, and sugar way more expensive. No one wants that, but it's not like we can avoid El Niño. It's just a natural part of Earth's climate that's been happening for millions of years. It all starts in the Pacific Ocean. And since this ocean is so huge, whatever happens there kind of ripples across the whole planet. You see, under normal climate conditions, tropical winds blow west along the equator, pushing warm surface water from South America toward Asia. As that warm water moves away, cold water rises up from the deep ocean to take its place. We call this process upwelling. But the Earth always likes to surprise us, right? So, from time to time, a cycle known as ENSO shows up and breaks those rules. This natural cycle is divided into 3 phases: La Niña, El Niño, and an in-between stage where things are relatively quiet, known as ENSO neutral. La Niña is the cold phase. When it happens, those tropical winds get even stronger than usual, shoving more warm water toward Asia. Near the Americas, super cold water from the deep ocean rushes up to the surface. This shifts the jet stream, those high-altitude winds that steer our weather further north. For the US, a La Niña year usually means a warmer, drier south and a much colder, rainier north. It also tends to make hurricane seasons in the Atlantic way more active and dangerous. El Niño is the exact opposite. It is the hot phase. This is when the tropical winds weaken or even reverse. The sea surface temperatures can reach 9 degrees Fahrenheit above their normal levels. Instead of being pushed away, all that warm water flows back east toward the Americas. This pulls the jet stream way south of where it usually is, and that changes the weather completely. Areas in the northern US and Canada stay warmer and drier than usual, while the southeast and the Gulf Coast get soaked with constant rain and flooding. El Niño and La Niña episodes tend to happen every 3 to 7 years, with each phase usually sticking around for about a year. But don't expect a fixed schedule. It happens. At the beginning of 2026, the world is watching it all unfold again. A weak La Niña is finally fading away, and little by little, it's turning into an El Niño. And experts think it could be a massive one. All the signs from the ocean and the atmosphere show a powerful El Niño pattern picking up speed as we head toward the fall. If the water keeps warming up at this rate, some meteorologists believe this event could become exceptionally strong. A Super El Niño is on a whole different level. It happens when the Pacific gets so warm that it basically throws the world's weather off balance. This can lead to much more extreme weather shifts. Instead of just a little more rain, you get massive floods. Instead of a short period of dry weather, you get a serious drought. This event also pushes storms into places they don't normally go, and that ends up affecting the whole world. If you're not a big fan of summer, I have bad news. A new Godzilla El Niño is probably going to push global temperatures to record-breaking heights. It's going to be unbearably hot. The last time the world had to deal with a Super El Niño was back in 2015. That year, the water in the Pacific got incredibly hot, and that set off a chain reaction of disasters around the globe. The hurricane season was unlike anything we'd ever seen. Usually we see 4 or 5 tropical cyclones in the Pacific, but in 2015, there were 16. That's insane. At one point, 3 massive Category 4 hurricanes, named Kilo, Ignacio, and Jimena, were all spinning at the exact same time out at sea. That was a first since we started keeping track. Luckily, none of them actually hit land. But we weren't always that lucky. In July 2015, Hurricane Dolores sent record-breaking rain into Southern California, causing over $50 million in damage. Later that same year, Hurricane Marty hit the coast of Mexico, leading to another $30 million in losses. South America was hit with way more rain than usual. Rivers in Argentina and Paraguay overflowed, forcing thousands of people to evacuate. Because of El Niño, 2015 became the hottest year on record at that time, and it brought terrible droughts. In Ethiopia, for example, some parts of the country got less than a third of their usual rain. Crops failed big time, and over 8 million people were left without enough food. So, are we going to face something that intense again? Well, it's hard to say. Most experts agree that an El Niño is in fact coming, but we're still not sure about its strength. Early data shows everything from a weak event to a record-breaking Super El Niño. Scientists are watching it closely, but they need a few more months to see how it actually behaves. The El Niño is expected to show up by summer. Usually we don't feel the effects right away, but since this one is moving so fast, we might start seeing weird weather sooner than usual. One big change we can expect has to do with the Atlantic hurricane season. And that's good news for the US. Usually, the El Niño lowers the overall numbers of hurricanes in the Atlantic. That's because it creates high air pressure and stronger winds high up in the sky that basically rip the storms apart before they can grow. In this part of the US, this makes the whole atmosphere more stable, which stops small storms from powering up into giant hurricanes. But the main impact of El Niño usually happens in winter, and it messes with the snow. If you live in the northern US or the Midwest, you will probably see a lot less snow than usual. Of course, these are all just predictions based on what happened in previous years, but it's not a perfect science. After all, we never see the exact same weather 2 years in a row, and when you throw an El Niño into the mix, things get even more unpredictable. One thing's for sure, since this phenomenon affects millions of people, experts have to keep a close eye on it every year. Seasonal forecasts for El Niño and La Niña too show how the weather is likely to change, helping authorities plan ahead for energy and water needs. This way, cities can prepare for too much rain or severe drought, and farmers know what to expect for their crops. But most importantly, weather alerts let people find shelters and get communities ready before disasters hit, and that saves lives.
We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the Enso cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the Enso cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication, both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, You must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the U.S. every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain, and that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
The air is bone dry and the wind is out of control. You feel like you're standing in front of a fireplace, but you're not. You're standing in your backyard about to grill up a feast when you suddenly see the trees shaking uncontrollably. Leaves are falling like confetti. The wind just blew your last piece of laundry into the great unknown. You look around and everyone else is just as confused and scared as you are. In the distance, you see a red horizon of fire in the forest and a large vortex touching the sky. You drop everything and make a break for it. You'll be lucky to outrun a tornado. They usually move at around 30 miles per hour, but can reach up to 70. Imagine running away from a giant twister, hurtling towards you at Usain Bolt speed. The roads are crowded with people trying to find shelter or just get out of town. You get in your car and try to start it, but the wind knocks a sign over. It smashes your windshield. Anyway, a big tornado is powerful enough to swing your entire car around. You gotta go on foot. Best bet? Head for your buddy's house. They have a deep basement stocked with supplies. Whenever a tornado flies on by, try to take cover somewhere underground. If you don't have a basement, avoid any windows and try to stay underneath something sturdy to protect yourself. You're running to your friend's place. Everything around you is getting swept up by the insane winds. But when you turn around, you see the tornado turning reddish. You can barely see it because of the debris, but the spinning vortex, it's on fire. It's a fire tornado. These spinning flame winds can reach 140 miles per hour and can be between 15 to 150 feet tall and as much as 500 feet wide. These monsters occur when tons of smoke get whirled around, so the thunderstorm starts to act like a tornado. By the way, many fire tornadoes can even occur in a bonfire and are called fire whirls. Next time you're camping or setting up your living room fireplace, check it out. You might just spot one spinning around in there. Anyway, it's getting closer and closer, throwing ash all over. It's already pretty hard for you to see where you're going. You use your hands to wave off some of the smoke and ash flying around your face, but it's useless. You keep sprinting as fast as you can until you spot a huge truck. Just park right there in the middle of the road. You crawl underneath. It's one of those trucks that has like 20 wheels. They look so big and heavy up close. Then you hear a creaking sound and a humming sound. The wheels, they look magical. Gracefully, they start lifting off the ground, as if the truck's part of some Vegas magic act. As the tornado gets closer, the wheels rise higher. Better to be far away from here when the truck smashes back down to earth. You crawl out and keep running. You find a convenience store to take cover in, making sure not to stand too close to the glass. You head as far into the store as you can, ready to wait this thing out. But all around you, the land is burning. This fiery twister is a monster, and it's charging towards you. You look out in the distance and see another fire tornado wrecking another part of the city. In order for a tornado to form, it needs open space. That's why many of the tornadoes you see on the news happen in the same part of the US, where there aren't many mountains and it's nice and flat. But of course, they can happen anywhere. It's not normal to see tornadoes in the bustling downtowns of America's biggest cities. They need a lot of open space for the rotating vortex to happen. But today is not a normal day. A tornado forms in a supercell thunderstorm. That's when you have two different air temperatures going at it. The vortex you see in tornadoes forms when warm air and moisture come in from above. Below, it's a mess. The end result, the huge spiral funnel cloud we see in every tornado movie. Meteorologists can predict tornadoes somewhat by monitoring the amount of moisture in the air. Every second counts, so keep the TV on next time there's a storm brewing near you. But this doesn't really apply for a fire tornado. The winds are getting stronger and you're feeling the heat even inside the store. Outside, spiraling flamethrowers are torching everything in their path. It may be too late to find an underground shelter. You improvise a way to help protect yourself by hiding underneath the cash register. And now, you can't see anything. There's ash everywhere and the windows are all smashed. Thanks, tornado. Ash is one of the most dangerous parts of a fire tornado, unless you're not really into breathing or seeing. Your best bet would be to stay as low as you can to the ground. Since smoke rises, there might still be just enough oxygen down there. Crawling your way along will prevent you from getting struck by any flying objects or debris. The fires are now spreading, and there's a lot more smoke. The trees outside have caught fire, and there are glowing embers as far as the eye can see. These embers can travel more than a mile and can start fires on their own. Now that it's really going crazy, stuff in the store starts flying about, like the smoke wasn't bad enough. You feel like you're inside a snack-filled erupting volcano. It's only a matter of time before the table you're hiding under will get pulled up into the air. The sound inside the store is intense, like sitting next to a jet engine. You can't tell if you're sweating from the heat or from adrenaline. But suddenly, you see someone at the other end of the store waving at you, trying to tell you something. They have an underground storage room. You're saved. But getting there is going to be a real problem. You see, the table screw's getting loose, getting ready to fly into the air. You find a bottle of water next to you and rip a piece of cloth from your shirt. By using a wet cloth, you're able to filter out some of the nasty stuff in the air to help you keep breathing. So, you crawl your way out from underneath the table and make your way to the underground storage room. But the ground is covered with broken glass, and there are cans and stuff everywhere. Even the cans are starting to heat up. You crawl like a sloth, trying to avoid anything pointy. The fire tornado is still out there, and it's getting even closer. You finally make it, and the clerk pulls you down the stairs. It's dark, but there's a single battery-powered lamp to help you see. When it comes to fire tornadoes, it's best to just wait it out. Most of these firestorms don't last that long. So you relax, or try to, and wash your face in a nearby sink. You wipe off all the black ash from your face and breathe normally again. But as you get a bit more relaxed, you feel the ground shaking. Everything around you starts to fall. You and the clerk duck behind a pile of canned goods. Then the tornado takes it up a notch. The store above you gets lifted up off the ground. The only things left, steel and concrete foundations and a couple of random columns. The steel door that's separating you from the outside is barely holding it together. You can see the screws getting loose. You can actually see fire enter the storage room. Everything in the room gets toppled over in an instant. The wind is even louder than before. But then, it's over. Those few minutes felt like hours. You and the clerk climb out and see, well, not much to be honest. The convenience store looks like it got ripped off like a Band-Aid. And all around you, a town you can't even recognize anymore. The big problem with these fire tornadoes is the fires they leave behind. They can ruin towns, forests, farms, and lives. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, A giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reached the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
Right now, as you read this, two colossal slabs of rock are locked against each other beneath the streets of Oakland, California. It sounds like nothing to an unprepared person, but the problem is that they're pressing harder with every passing year, storing up energy like a spring that's been coiling for more than 150 years. Roughly 30 feet below the sidewalks where people walk their dogs and grab their morning coffee, a geological clock has already run out. And scientists now know with uncomfortable precision exactly what happens when it finally lets go. This is the story of the Hayward Fault, one of the most dangerous strips of land in the United States. And the extraordinary computer simulations that are finally revealing the full picture of what the next big earthquake will do to millions of people. Let's start with the fault itself, because the Hayward Fault is not some distant geological curiosity hiding far out in the wilderness. It runs for roughly 74 miles right through the heart of California's East Bay, directly under neighborhoods, schools, hospitals, and highways, in cities like Oakland and Berkeley. More than 2 million people live or work along its path. And it is, by scientific consensus, overdue. The last time the Hayward Fault produced a major rupture was in 1868. That earthquake, estimated at magnitude 7, was devastating by the standards of the time. It flattened buildings across Hayward and sent shockwaves all the way into San Francisco. But here is what makes today's situation so much more serious. The fault's average cycle between major earthquakes is around 140 years. We are now more than 150 years past that last rupture. The clock has not just run out, it ran out over a decade ago. The numbers from the United States Geological Survey make this concrete. There is roughly a 1 in 3 chance of a magnitude 6.7 or larger earthquake on this fault within the next 30 years. But the Hayward Fault doesn't operate in isolation. When scientists factor in connected faults in the region, including the nearby Rogers Creek Fault to the north, the probability of a major rupture somewhere in the system climbs to 72% by the year 2043. That is not a distant hypothetical. That is a near certainty within most people's lifetimes. So what exactly happens when it breaks? For decades, the honest answer was, we're not entirely sure. General earthquake models existed, but the Bay Area's geology is complex, a patchwork of hard rock, soft sediment, deep basins, and hill formations. And predicting how seismic waves travel through that maze was beyond the computing power available. That changed recently. Researchers at Lawrence Livermore National Laboratory and Lawrence Berkeley National Laboratory used some of the most powerful supercomputers on Earth to run 50 separate simulations of a magnitude 7 earthquake on the Hayward Fault. Each simulation varied the details, where exactly the rupture starts, how the slip spreads across the fault surface, how fast the break travels. The result is not one prediction, but a rich, detailed map of possibilities, showing not just where shaking will occur, but how intense it will be, how long it will last, and why certain neighborhoods face dramatically higher risks than others. What they found should reshape how every Bay Area resident thinks about where they live. The most important takeaway from these simulations is this: the ground does not shake equally. Location matters enormously, and the differences are not subtle. Take the Eastern Hills, places like Orinda and Moraga. These communities sit on layers of softer sedimentary rock, and that geology acts like an amplifier. In a major Hayward Fault earthquake, shaking in these areas could be up to 50% more intense than in western neighborhoods sitting on solid bedrock. That is not a rounding error. That's the difference between a building that survives and one that doesn't. And then there's Livermore Valley, which faces a different but equally serious problem. The valley sits in a geological basin, and seismic waves behave strangely inside basins. They bounce around, trapped between the basin walls, unable to escape. Instead of the shaking lasting the usual few seconds, simulations show it could continue for more than 2 minutes in Livermore. 2 full minutes of sustained, violent shaking. For pipelines, warehouses, and industrial infrastructure, that duration is potentially catastrophic. In Oakland and Berkeley, right on top of the fault line itself, the main danger comes for what scientists call directivity pulses. When a pulse ruptures, the break doesn't happen all at once. It races along the fault, and in doing so, it flings concentrated bursts of energy forward like a wave from a moving source.
Communities directly in the path of that forward momentum get hit with sharp, powerful pulses that are particularly destructive to tall buildings. Skyscrapers and high-rises in these cities face the highest risk from this effect, with ground accelerations that can reach the equivalent of the full force of gravity, enough to overwhelm structures that were not built with this specific threat in mind. Meanwhile, on the western side of the Bay Area, underlain by the hard Franciscan bedrock, things look noticeably different. Ground acceleration there could be 20 to 50% lower than in the highest risk zones. San Francisco itself will certainly feel the earthquake, but distance and solid geology provide meaningful protection. This does not mean western neighborhoods are safe. It means they are safer, relatively speaking. To understand why geology creates such stark differences, it helps to think about how seismic waves actually move. When a fault ruptures, it sends waves radiating outward in all directions, much like dropping a stone into a pond. But unlike water, the ground is not uniform. Hard bedrock transmits those waves quickly and efficiently, so energy passes through without lingering. Soft sediment, by contrast, slows the waves down, compresses them, and forces them to grow taller and more violent. The same way ocean waves rear up and crash when they hit shallow water near the shore. The Bay Area sits on an extraordinary variety of ground materials, which is precisely why two neighborhoods just a few miles apart can experience the same earthquake in dramatically different ways. The simulations capture this complexity in finer detail than any previous model, and the results make clear that geology is not just a background detail, it's the single biggest factor determining who gets hurt and who walks away. What makes these simulations genuinely groundbreaking is that they don't just produce abstract data, they produce actionable intelligence. Engineers can already use these results. For skyscrapers in Oakland and Berkeley, the pulse wave risk means buildings need reinforcement specifically designed to absorb those sharp, sudden jolts rather than the slower, rolling motion of distant earthquakes. In Livermore, foundations for new construction must account for extended shaking durations, not just peak intensity. In the eastern hills, slope stability becomes a critical concern. Steep hillside homes face elevated landslide risk when shaking amplifies. For public infrastructure, Bay Area Rapid Transit, BART, and the region's freeway systems are being prioritized for retrofitting based on the directivity cone maps and simulations produced. The fault doesn't just threaten buildings, it threatens the transportation networks people will desperately need after a major event. And for ordinary residents, the implications are personal and practical. Securing heavy furniture, water heaters, and bookcases reduces injury risk. Early warning apps can provide seconds of notice before shaking arrives, enough time to drop, cover, and hold on. Emergency supplies for at least 3 days are not excessive preparation. For a region this exposed, they are basic common sense. The science of earthquake prediction is moving fast. These simulations are already being extended to the San Andreas Fault, modeling potential magnitude 7.5 or larger events. Higher resolution subsurface mapping will push the models to even finer detail. But the Hayward Fault simulation already tells us something profound. We do not need to be helpless in the face of this threat. The ground beneath the Bay Area is not a mystery anymore. We know where the danger concentrates. We know why some neighborhoods will shake harder, why some valleys will shake longer, and why some buildings face risks that others don't. The question is no longer whether this earthquake is coming. The question is whether we will be ready when it does. Take a look at the map of Europe and find Spain and Portugal. These countries are connected to the continent, yet they seem to lie on a separate piece of land. This area is called the Iberian Peninsula, and right now, as you're watching this video, it's rotating clockwise, slowly moving closer to the rest of Europe. This movement is extremely slow, and of course, you wouldn't feel anything if you were standing there. But over time, this rotation could significantly change the geography of Europe. So, why is this happening? Several large and many smaller tectonic plates cover the planet.
These are massive sections of the Earth's crust, about 60 miles thick, resting on the upper layer of the mantle. And these giant plates are constantly moving, not fast enough for us to feel, but relentlessly enough to reshape the entire planet over tens and hundreds of millions of years. So, why do they move at all? No one knows for sure, but the most popular theory suggests that when one part of a plate sinks into the mantle, it pulls the rest along with it. It's similar to a large iceberg. When one part goes underwater, another part rises. Of course, many other factors are involved, such as temperature and gravity, but let's not dive too deep. What matters is that the tectonic plates beneath our continents are always in motion. So, the Iberian Peninsula rotates clockwise because the African and Eurasian tectonic plates are slowly colliding. Thanks to this massive and chaotic process, it's difficult to see a clear boundary between these plates on the Earth's crust. Instead of a sharp line, the boundary bends and shifts, absorbing energy in some areas and releasing it in others, deforming the whole region. But you won't see this boundary on a regular map of continents and countries. The map of tectonic plates looks a bit different. They're much larger and lie beneath our continents. Some plate boundaries are even underwater. The Iberian Peninsula itself sits directly on the boundary between the African and Eurasian plates. But how fast are they moving toward each other? Take a look at your fingernails. They have something in common with these two tectonic plates, which move at about 4 to 6 millimeters per year. That's roughly the average speed at which your fingernails grow. So how did scientists figure this out? Thanks to large-scale research, specialists studied records of numerous earthquakes in the region, the geometry of faults during seismic activity, and also analyzed data from hundreds of GPS stations that track how our planet shifts by fractions of a millimeter each year. The analysis of all this data showed that the tectonic plate boundary behaves very differently on either side of the Strait of Gibraltar, which separates Europe from Morocco. In the eastern part of the strait, the Earth's crust acts like a buffer, absorbing the stress between the two plates. In the western part, this buffer disappears, and Iberia collides with Africa on one side and with Europe on the other. This uneven movement causes the entire peninsula to rotate. But what does this lead to, and why is it important for us to know? In 1755, a powerful earthquake struck off the coast of Lisbon. It partly destroyed the city and triggered a tsunami in the Atlantic Ocean. After that, there were many other smaller yet still destructive seismic events. Modern research helps identify the most dangerous zones along the plate boundary and allows scientists to assess earthquake risks better. Of course, there's still a lot of work to be done. To understand seismic activity fully, scientists need to know how the plates behaved in the past. The first high-precision satellite measurements only appeared around 1999. We don't know exactly how the plates moved millions of years before that, which makes reconstructing geological evolution extremely difficult. So right now, we're witnessing changes in the shape of continents. Are similar changes happening elsewhere? Absolutely. One of the most striking examples is the Great Rift Valley, which stretches from the Afar region down to Mozambique. The East African Rift System lies at the very heart of this massive valley. This is what scientists call the zone where the African continent is slowly breaking apart. Recent satellite images and geological studies have shown that the rift is expanding quite fast and will eventually reshape the entire region. But how fast exactly? About 7 millimeters per year. According to estimates, the entire process will take tens of millions of years. On a planetary timescale, that's relatively fast, but for us, there's no need to worry, at least for now. All these geological changes may seem frightening. You probably imagine massive earthquakes, floods, panic, and destruction. Cities vanish, giant cracks appear in the ground, and chaos is everywhere. Yes, something like that will likely happen, but in reality, these changes will also bring many advantages. As the East African Rift System continues to split, an ocean basin will form, transforming the climate and environment of the entire region. Large areas of land will sink below sea level, and the overall sea level will rise. Essentially, this massive separation will give birth to an entirely new continent. New coastlines will appear, where people will build ports. New shipping routes will be created, significantly improving the region's economy. Access to water will transform agriculture and create many new opportunities for locals. Animals that never lived there before will appear, along with new species of fish and insects. Of course, competition for emerging resources will begin. Countries will redraw borders, there will be a lot of arguments and conflicts, which will lead to great tension. But this is not surprising. People always do this. To better understand what this process will look like, we can look at the past. Imagine a large landmass where people live and build civilizations. Then, over time, this land sinks underwater and separates a small piece of the continent from the larger one. This happened relatively recently in human history, even though most people don't know it. Take a look at Great Britain. Have you ever wondered why it's separated from the European continent? Now look at the North Sea. Thousands of years ago, there was no water here. Modern Britain was connected to Europe by a vast landmass called Doggerland. Around 12,000 years ago, the last major ice age was coming to an end. Doggerland was a region of gentle hills, wetlands, dense forests, valleys, and lagoons. Hunter-gatherers lived there. During different seasons, they moved across Doggerland, catching animals, fishing, and gathering nuts and berries. They lived there pretty well and comfortably for a long time. But around 6,000 years ago, these people were forced to abandon their homeland. When the Ice Age ended, massive glaciers began to melt. Sea levels rose dramatically. Water flooded Doggerland and forced people to leave. This was a long process and not a sudden surprise. The water level rose over many centuries. During this time, local populations migrated to what is now Great Britain and the Netherlands. But if Doggerland is completely underwater, how do we know it ever existed? Archaeologists and fishers discovered many artifacts in seabed sediments that indicate human presence. There were ancient bones and tools dating back 9,000 years. These discoveries sparked great interest among British and Dutch researchers, leading to large-scale studies of this submerged region. But here's the most interesting part of this story. In a way, when we look at Doggerland, we are looking at ourselves. What happened to people there is happening to us today. Global temperatures are rising, glaciers are melting, and sea levels are increasing. Over the next few thousand years, warming will likely intensify. Many land areas will be submerged. Hundreds of millions of people will be forced to migrate, and the world map will take on an entirely new shape. In any case, there's no need to panic. If those guys thousands of years ago managed to survive these changes and relocate to safer areas, then in the modern world, with advanced technology and global communication, large-scale human migration will be far more comfortable.
Well, scientists have just reconstructed one of the biggest volcanic eruptions in Earth's history, and the more they dug into it, the worse it got. Over 350,000 years ago, the center of New Zealand's North Island looked completely different. The mountains we see today weren't there yet. The climate was colder, and the region was literally stuck in an ice age. Winters were harsh, and temperatures stayed low year-round. Everything looked calm and quiet, well, on the surface. Underground, something was building and building until it snapped. A super eruption hit the Taupo volcanic zone, the Whakamaru eruption, one of the biggest ever recorded on Earth. Now, it wasn't a single mountain that produced it. It was a whole volcanic system stretching from Wakari White Island in the north toward Ruapehu in the south. A weak zone in Earth's crust was getting stretched and broken at the same time. One force was pushing magma up, another was pulling the land apart. That combo powers this region even today, but back then it got extreme. The eruption blasted so much material that ash spread across huge parts of New Zealand. In some areas, it was so thick that it buried the land under layers of volcanic rock and debris. It was like dumping miles of powdered stone over a country. Today, that same zone hosts hot springs, bubbling mud pools, and steam vents. And all this sits on the top of the same, if a bit quieter, system. The Taupo volcanic zone has been active for about 2 million years, having produced at least 4 supereruptions. Those weren't small events. On the Volcanic Explosivity Index, they hit level 8, which is, so far, the maximum category. We've only had a few dozen such eruptions on Earth. The most recent one was the Aroa Nui eruption about 25,300 years ago. That one was even bigger in volume and created what is now Lake Taupo. In other words, Whakamaru wasn't a random disaster. It's what this volcanic system does from time to time. Supereruptions are still one of the hardest problems for scientists. Because how does a huge amount of magma sit underground, build up, and then just explode almost at once? To figure that out, researchers read the leftovers, ancient deposits. There are 2 main types of those. One is flow deposits, left by fast-moving avalanches of superhot rock, gas, and ash called pyroclastic flows. All that mass rushes along the ground like a burning flood and later solidifies. The other kind of evidence comes from fall deposits. Those are lighter materials like ash, crystals, and volcanic glass. They get blasted high into the air and then rain back down to the ground. Now, the problem is time. Most of these deposits don't survive. They get eroded, buried, and broken apart. What's left is often scattered across huge distances. The Whakamaru supereruption left exactly this kind of mess behind. Huge pyroclastic flows form thick layers of dense volcanic rock across the Whakamaru and King Country regions. Farther out, ash and pumice spread much wider, covering large parts of the North Island and even reaching into sections of the Pacific Ocean. To piece all the traces together, researchers first had to track down where the fragments actually came from. They built a database of volcanic deposits and matched them using a chemical signature. You can find it locked inside tiny bits of volcanic glass. Each eruption leaves a slightly different chemical mix. Using that method, scientists checked more than 30 sites across New Zealand and the South Pacific. And even though the samples were spread so far apart, they all matched the same source, the Whakamaru supereruption. So, finally, researchers could piece together what happened during one of the biggest eruptions in Earth's history. At the start, the central North Island likely had a large lake in the middle of it, similar to modern Lake Taupo. Then, magma broke through the surface right into that water. That's where things escalated fast. When magma hits water, the water instantly turns into steam. That can make an eruption extremely destructive, and it's probably what kicked off this one. At first, one huge magma chamber was likely feeding the eruption, but soon the situation changed. The eruption continued, and the lake was destroyed and filled in by volcanic material. And once the water was gone, the style of the eruption shifted. It became drier and more direct. And underground, something even bigger was happening. Instead of one magma chamber slowly emptying, the system split into numerous active zones. At least 5 separate magma bodies may have started erupting at the same time. The ash output became extreme. Most of the North Island and even distant Chatham Island ended up under roughly 12 inches of volcanic material. Closer to the source, up to 15 feet of deposits covered the ground in some regions. Then came the pyroclastic flows, fast-moving currents of superheated gas and rock. Near the eruption zone, they left behind deposits hundreds of feet thick. When you add everything together, the numbers are hard to picture. The eruption blasted out roughly 550 cubic miles of material. If you spread it evenly across all of New Zealand, the entire country would end up buried under about 30 feet of volcanic debris. But the scariest thing is that the Taupo volcanic zone is still one of the most powerful volcanic systems on Earth. Supereruptions like Whakamaru are rare. But the system has produced many smaller eruptions too, and those are capable of reshaping large regions too. That's why this research matters not only for geologists. We must understand how these eruptions switch from single-source magma to multi-chamber catastrophe. This way, we'll be able to figure out what such a system is capable of doing in the future. And New Zealand isn't the only place where scientists worry about giant volcanic systems. One of the most famous examples is Yellowstone in Wyoming, Montana, and Idaho. Some experts think it might be overdue for a massive eruption. The last one happened around 70,000 years ago, according to the U.S. Geological Survey, and the last true supereruption occurred about 640,000 years ago. And yes, the volcano is still active, even though not in the imminent disaster way most people imagine. You can see that activity right on the surface. The Grand Prismatic Spring is the biggest hot spring in the U.S. and the third largest in the world. Its famous bright colors come from bacteria living in different temperature zones around the spring. The water itself hits about 158 degrees Fahrenheit. This spring is boiling, and volcanic activity is what's driving this process. The magma system below Yellowstone is massive. It may be even larger than we thought earlier. If it fully erupted one day, it could release around 2,500 times the energy of Mount St. Helens, and that eruption was a devastating event. In 1980, a 5.1 magnitude earthquake triggered the north side of the mountain to fall away, which created the largest debris avalanche ever recorded. The blast flattened about 230 square miles of forest and took the lives of 57 people. Anyway, all that underground activity doesn't mean Yellowstone is ready to blow tomorrow. In fact, it gets about 700 to 3,000 small earthquakes every year, and most are so weak that people don't even feel them. It's just the ground constantly shifting and adjusting. But if a full supereruption ever happened in that region, it would be a full-blown disaster. First, pyroclastic flows would rip through parts of Montana, Idaho, and Wyoming. Then the ash would start falling. It would spread across the entire U.S. Roofs could collapse under the weight of all that heavy ash in some areas. Air quality would drop, and water systems would get contaminated. Such a chain reaction could trigger a global food crisis, but it's just a hypothetical situation at the moment. We should remember that even though supervolcanoes are terrifying, they're rare. It's often the smaller volcanoes we should look out for.